guys, how's it going? This is dedicated to my team innovation. I've just said in my office, that I'm in the office and then you kind of get bored. You're looking at your laptop, you're looking at your printer, you're looking at your phone, desktop, then you realize something's missing, and this is what is missing. So actually this is a 1 inch, it's a 1 inch styrofoam. It's very delicate. Usually my specialty is cardboard, but I thought let me challenge brings growth. All right, so the only thing left is, you can see that's my rudder, so my elevators are all set. I was having a conversation about whether I have the one-piece rudder. This rudder can actually do both, can be used for directional control and also lateral, but it may be a bit sudden when you use your rudder. That's why we use ailerons. So ailerons, there are some phases of flight actually more effective than rudder, but for an RC, because of complexity and also because of weight balancing, you can just decide to use your rudder. But I've decided I'm going to use ailerons. I was also thinking about flaps, so I'm just going to extend. Remember, flap on the wing is a ratio. Everything on these aircraft must be ratios. Ratios must be guaranteed. And then as a front view, so I'm just going to put my motor there, maybe a 980 kilowatt. That should do. Maybe a 4-inch, let me say maybe 5-inch, so 10-inch, 8 to 10-inch props. And then I'm left with a landing gear. And then I've already trying to balance center of gravity. So center of gravity must be ahead of the main landing gear. And there's definitely a reason for that. We're looking at weight distribution. If you actually put your center of gravity with your main landing gear, it means your main landing gear will take 100% of the loads. Chances are it will collapse. And that's why we put it several inches, so that it takes 85 to 90% of total loads, where the nose wheel takes between 10 to 15%. Wow, all right guys, so let me continue. I'm still waiting for your models. I'm waiting for your pictures. Those who are doing exams, congratulations, all the best. The others, remember PTC, patience, time, and cash. You need to create time. You need to be very patient, very patient, and it will take finances. I've asked the technician to source cardboard. I'm waiting for his feedback. So if anybody needs cardboard, because sometimes you realize without drive or finance, and some of these things you have to buy, you can't just go to a supermarket and ask them for cardboard. They're going to give you the small piece. This one needs a full sheet, a sheet the size of my table, like 8 feet by 4 feet. If you have any sheet, whether it's styrofoam or whether it's cardboard, I believe you can make the best use. Later on, I'm going to tell you some of the challenges, because as I make this, I'm also trying to analyze where the challenges coming from and how to overcome these challenges. And then the other one, I'm going to put dimensions, actually create a flight manual for this, so that we're able to determine the CL over CD, that's L over D ratio. Also, we can be able to get our thrust weight ratio. Then we should be able to get our drag ratio, what is known as drag loading. And then guess what, guys? Have you ever heard of you guys have heard of a coefficient of lift? Well, guess what? There's also a coefficient of pressure. And I bet you didn't know that lift equals weight. Okay, you know lift equals weight, but guess what? That's half of the truth. Lift is never equal to weight, which, if we're going to do a aircraft design class, I'm going to prove to you that lift is never equal to weight. In fact, lift equals weight plus an additional force of about 6%, depending with the type of aircraft. So anyway, guys, there you have it. So that's a short Tucano Mk 812. Short Tucano 812.